Welcome back to The Explainer. Have you ever walked through a stunning, beautifully finished house and just wondered what on earth the wiring looks like behind the walls? Well, today we're tearing off the drywall. We're digging into an exclusive code-based intelligence brief for the Acme platform. From the outside, you've got this thriving, functional customer data and analytics platform. But beneath that surface, we're looking at a hidden crisis of technical debt that is literally, silently, putting the whole business on the line. So let's jump in and diagnose exactly what's going on. Here is a quick look at our agenda for today's diagnostic report. We're going to run through the platform health check, diagnose the symptoms of code fragmentation, map out the parallel systems and fractures, find those nasty integration blind spots, talk about the immediate business risks, and then wrap up with a clear consolidation path.
Okay, Section 1, the platform health check, the facade versus the foundation. We've got a massive disconnect here between what users see and the reality engineers are actually living in. On the surface, everything looks golden. The platform is live, customers are actively logged in, and the product team is successfully shipping new features on schedule. But the code-based reality? It's a completely different story. We're talking 187 dependencies scattered across 4 different programming languages. You've got TypeScript on the front end and API, Python handling data, and Rust running the infrastructure. It is highly inconsistent, and the technical debt isn't just sitting there, it's actively compounding.
To really put a metric on this chaos, the intelligence brief hits the Acme platform with a fragmentation score of 74 out of 100. Now, why does that specific number matter? Because in this framework, anything over 70 means you've hit severe structural fragmentation. This isn't your standard run-of-the-mill tech debt. A 74 means the debt is actually accelerating. Every single feature you add today makes the entire system exponentially harder to maintain tomorrow.
And that fragmentation score translates straight into an overall health rating of grade C. The code base functions, sure, but it is incredibly fragile. It's honestly the technical equivalent of cruising down the highway at 70 miles an hour with your check engine light flashing bright red.
The report actually uses this brilliant metaphor to describe it. Picture a kitchen where 4 different chefs have been working simultaneously. They've each got their own knives, their own recipes, and none of them have any idea what the others are cooking. The meals still eventually make it out to the dining room, which is why the customers are happy, but the kitchen itself, it's becoming an absolute nightmare to navigate. This is exactly what happens when you have disparate developer teams or even multiple AI coding assistants working at breakneck speed without a shared central coordination layer.
Right, moving into Section 2, symptoms of code fragmentation. Let's start diagnosing this chaos. The most glaring symptom of this multi-chef kitchen is just the staggering redundancy of basic tools. To do one of the most fundamental things in web development, fetching data from the internet, this codebase is running 5 competing HTTP clients simultaneously. Because, why use one when you can use Axios, Node Fetch, GOT, requests, and HTTPX all at the exact same time? Think about the massive security risk there. If a vulnerability drops for how HTTP requests are handled, your team can't just patch one tool. They have to hunt down and coordinate fixes across 5 separate surfaces. And it definitely does not stop at HTTP clients. When you stack up the rest of the redundant tooling, it's wild. 4 separate authentication systems fighting to manage identities. 5 different ways of handling application state, which means user data behaves completely unpredictably depending on what screen you're on. 4 different input validation systems. 4 totally different logging and observability formats, so when something breaks, your incident response team has to try and stitch together a timeline across 4 different logging systems. The structural inefficiency is just massive. Let's move to Section 3, parallel systems and fractures. This is all about structural duplication. As we go deeper into the implementation layer, the codebase literally splits into parallel realities. Take the main dashboard screen. We actually have a dashboard.tsx and a dashboard v2.tsx. Both of these are fully live right now. Some users get routed to the old version, some get the new one. Meaning, if you ship a slick new feature or fix a bug in version 2, the users stranded on the original dashboard are entirely left out in the cold. It makes feature releases partial by default, and it completely ruins any A/B testing you might be trying to pull off. But honestly, the parallel dashboards aren't even the scariest part. The highest risk duplication here, by far, is the dual authentication paths. The actual process of verifying a user's identity runs through 2 completely different files, auth.ts and auth.v2.ts. Both are active. This is a terrifying vulnerability. You patch a critical 0-day flaw in one system, and the users routing through the other path are just left sitting there as exposed targets. Which leads us directly into Section 4, the integration blind spots. This is exactly where things break silently.
The real danger zones are the boundaries where these different languages attempt to talk to each other. Let's focus on the boundary between the TypeScript application services and the Python data pipeline. They share a database, but there is zero formal schema enforcing how they communicate. They're just operating on the blind, unvalidated assumption that they both understand database columns and null values exactly the same way. If they don't, either side can write data that the other side literally cannot read. The result is silent data corruption. No alarms, no error logs, the data just rots from the inside out.
Moving to Section 5, immediate business risks. Let's look at the commercial fallout. Let's translate these technical fractures into real-world business impact, because when you're running dual authentication systems and these wildly uncoordinated security surfaces, compliance, it's completely off the table. Getting formal security certifications like SOC 2 or ISO 27001 is structurally impossible for Acme as it stands right now. And that's not just an engineering complaint. That limits your enterprise sales, it destroys insurability, and it completely shatters customer trust.
Then there's the second massive business risk, stemming from those integration blind spots we just covered. Since there's no formal contract between the TypeScript app and the Python pipeline, that silent data corruption is a daily reality. Meaning, the analytics dashboards your customers rely on to make their own critical business decisions, they could be displaying completely incorrect numbers right now. And the kicker? Your team wouldn't even get an alert. You'd only find out when a furious customer finally calls up support. Finally, Section 6, the consolidation path. It's time to talk about the treatment plan.
So, how do we fix it? The incredibly good news here is that the platform absolutely does not need a ground-up rewrite. Do not throw it away. It just needs a methodical, heavily prioritized cleanup. Here is the exact 5-step path to consolidation. First, decommission that old auth.ts file immediately and route everyone to authv2.ts to close that massive security gap. Second, merge the dashboard versions and delete the duplicate, so all users are finally on the same page. Third, define a formal JSON schema contract at that dangerous TS to Python boundary to stop the silent data rot. Fourth, standardize those 5 HTTP clients down to just one, Axios. And fifth, lock down the state management to Zustand. Pick your tools, delete the rest. This is bounded, highly achievable engineering work.
But to actually get this cleanup started, technical leaders have to face the current reality of their codebase head-on. So I want to leave you with this provocative question straight from the intelligence brief. If both authentication systems are active right now, how do you know which users are being routed through which path? And honestly, does anyone on your team actually know the answer to that? It's a sobering thought, but answering it is step one toward a unified, healthy platform. Thanks for joining me on this deep dive into the Acme codebase, and I'll catch you on the next explainer.